This is Chapter 9, Section 3. Our objectives in this section is to add and subtract radical expressions. Also, we're going to multiply radical expressions. All right, so similar to fractions that have common denominators, you can add and subtract fractions with common denominators. Well, same kind of concept with radicals. As long as whatever is under the radical matches exactly, then you're allowed to add and subtract them. So this is saying 5 square roots of 2 minus 1 square root of 2. So of course 5 minus 1 is 4. So this is equal to 4 square roots of 2. If the radical matches exactly, it makes them like terms. If the radical is what's under the radical, I should say the radicand, doesn't match exactly, they're unlike terms, so you can't add and subtract them. All right, so in letter B, they all have a square root of 5 attached to it. So here we're going to add 3 plus 8, which is 11. 11 minus 14 is negative, negative 3 square roots of 5. All right. All right, so if you'll notice letter C, what's under the radical doesn't match right now. However, sometimes if we simplify what's under the radical, then we will see that they are like terms. So for example, letter C, the first term, we can simplify 18 to 9 times 2. And then 8 is 4 times 2. And of course, 9 and 4 are both perfect squares. So the square root of 9 is 3. The square root of x squared is x. So 3 square roots of 2 plus square root of 4 is 2. Square root of x squared is x. So now what's under the radical matches. So now these are all like terms. So 3x plus 2x is 5x. Square roots of 2 is our final answer. And then letter D. Now obviously 5 and 3 are simplified. So these are unlike terms. They're going to stay unlike terms. And then we're going to see if we can simplify square root of 12. So 12 would be 4 times 3. And of course 4 is a perfect square. So this square root of 12 simplifies as 2 square roots of 3. So now we have the square root of 5 minus square root of 3 plus 2 square roots of 3. So these two are like terms. So if you don't see a number, it's a 1. So 2 minus 1 is 1. So the final answer is the square root of 5 plus 1 square roots of 3. That is the final answer. Letter E. Those are like terms because what's under the radical matches. So basically we're adding 7x plus 1x. So 7x plus 1x is 8x square roots of 8. All right, letter F. We want to try to simplify these down to see if any of the factors are perfect cubes. Well, actually, both of these are perfect cubes. So the cube root of 125 is 5. A is not a perfect cube, so that stays under the radical. The cube root of 64 is 4, and then the A will stay under the radical. And then now they're like terms. So 5 minus 4 is 1. So the final answer is 1 cubed root of A. 1 cubed root of A is the final answer. And in Hogs, if you type that 1 there, it's going to tell you the answer is not simplified. All right, let's look at letter G. I have some shadows that I'm dealing with here. Now, if you notice the first two terms, and I think this came straight from Hogs, I can tell the way I typed it. The first two terms are square roots, and the third term is a cube root. So because that's a cube root and these are square roots, this is not like these terms. These are like terms together, but that's unlike the other two. So since these radicals match, we can do 8 minus 1. So 8 minus 1 is 7 square roots of y. And since this is not a like term, that is part of your answer. All right. Letter H. So I don't know. I'm trying to think of what I could divide 135 by. I got my calculator. So when I divide 135 by 5, I get 27. Well, I know that 27 is a perfect cube. So basically, let me write kind of what I'm thinking. So inside this radical is 27 times 5. 27 times 5 minus 5 cubed roots of 5. All right, so the cubed root of 27 is 3. So 3 would come out of the radical, but then I have to multiply 3 times negative 3. So cubed root of 27 is 3. 3 times negative 3 is negative 9 cubed roots of 5 minus 5 cubed roots of 5. So negative 9 combined with negative 5 is negative 14 cubed roots of 5. So that's the final answer, negative 14 cubed roots of 5. All right, and then letter I, it looks like everything inside the radical as far as the numbers are all perfect squares. So it looks like our z will be left by itself. So the square root of 25 is 5. So if we bring our 5 out, 5 times 4 is 20. So 20 square roots of z plus square root of 9 is 3. 3 square roots of z. And then the square root of 4 is 2. So we have to multiply 2 times negative 4, which is negative 14 square roots of z. Now all we have here are like terms, so we're going to add 23. 23 minus 14 is 9 square roots of z. All right, and that is the answer. All right, so now we're going to multiply. Now, you know, kind of like with fractions, you have to have common denominators to add or subtract fractions, but you do not have to have common denominators to multiply. Well, same thing is true with multiplying radicals. The radicals don't have to match. You're allowed to multiply unmatching radicals. So think about it though, if we had the square root of 7 and we're going to multiply it by the square root of 7, 7 times 7 is 49, and the square root of 49 is 7. So remember how I told you, if we square a radical, it cancels out that radical. So the square root of 7 squared is 7. So here we're going to distribute that 7. So the square root of 7 times the square root of 7 is 7. And then we have the square root of 7 times 14. So 14 times 7 is 98. So a positive times a negative is a negative 98. And then in my calculator, I'm putting what is the square root of 97. And the square root of 97 is 7 square roots of 2. I just stuck that right in my calculator. Ooh, these shadows are driving me crazy. So basically we have 7 minus 7 square roots of 2. Now those are unlike terms. We're not allowed to subtract them. So that is our final answer. 7 minus 7 square roots of 2. All right, letter B. We are foiling. So we have two binomials, so we are going to be foiling those. So we're going to do the first two terms. Square root 2 times square root of 2 is 2. Our outside terms, 4 or negative 4 times the square root of 2 is negative 4 square roots of 2. Now we're multiplying our inside terms. So 4 times square root of 2 is positive 4 square roots of 2. And then finally, 4 times negative 4 is negative 16. So if you can tell the way this is written, those two middle terms will cancel each other out. So basically we have 2 minus 16. Those zero out. And 2 minus 16 is negative 14, and that is the answer, negative 14. On letter C, square root 5 times square root 5 is 5. The outside terms, 5 square root of 5 times square root of 3 is square root of 15. The inside terms, same thing, we get square root of 15. And then we have square root of 3 squared. Square root of 3 squared is 3. Oops, plus 3. So now 15 can't be simplified. It doesn't have any factors that are perfect squares. So this is 1 square root of 15 plus 1 square root of 15. So 5 plus 3 is 8 plus 2 square roots of 15. And that's our answer. All right. And I'm just going to bear down on this other paper. All right, looks like we have one more example before our practice problems. So, same thing, we're foiling. So, square root of x squared of x squared is x. Then we'd have negative 1 square root of x, negative 1 square root of x. On the inside, we'd have 1 square root of x. I just wrote those ones to show you these cancel. And then we have 1 multiplied by negative 1, and we get negative 1. So our final answer is x minus 1. X minus 1 are unlike terms, so we can't go any further. All right, I think I gave you the answers on your practice problems. So go ahead and pause the video, see if you can figure those out, and then I'm going to work them out as well. All right, so number 1, these are like terms, so all we're going to do is subtract 2 minus 1. So 2 minus 1 is 1 square roots of 3. That's it, 1 square root of 3. On number 2, we are distributing. So we're just multiplying negative 2 times the square root of 8. Negative 2 times square root of 8 is 2 square roots of 8. And then negative 2 times positive square root 2 is negative 2 square roots of 2. But then that 8 can be simplified because it has a factor that's a perfect square. So 8 is the same thing as 4 times 2. 4 is a perfect square. Square root of 4 is 2, so we would wring out a 2. So 2 times negative 2 is negative 4 square roots of 2 minus 2 square roots of 2. Those are now like terms, so our final answer is negative 6 square roots of 2. Negative 6 square roots of 2. All right, on number 3, those are all unlike terms. So here at the bottom, I'm going to simplify. So 75 is the same as 3 times 25. 27 is the same thing as 9 times 3. And 20 is the same thing as 4 times 5. And all of those, I looked for a factor, the biggest factor that's a perfect square. So the square root of 25 is 5 square roots of 3. Square root of 9 is 3 square roots of 3. And the square root of 2 is 2 square roots of 5. So now I combine my like terms. 5 minus 3 is 2 square roots of 3 plus 2 square roots of 5. I'm going to check my answer on that one. Yep, that's exactly right for number 3. Number 4, those are like terms. So I'm just subtracting 5 minus 4, get 1, and 1 plus 2 is 3 square roots of x. 3 square roots of x. We're foiling number 5, so I'll do that over here. So square root 3 times square root of 2 is square root of 6. And then square root of 3 times negative square root of 3. So that's going to be minus 3. And then we have square root of 16. And finally we have negative square root 24. And then we're going to see what all we can bring out of that. All right, so square root of 6 has no perfect squares. 16 is a perfect square, so we have square root of 6 minus 3 plus 4, because 16 is a perfect square. And then negative 24, let's see, I need a little bit more room. So 24 would be, what's my biggest square root? I guess 4. 4 times 6, yep. So the square root of 4 is 2 square roots of 6. So now we have 1 square root of 6 minus 2 square roots of 6, which will be negative 1 square root of 6 plus 1. Or I could write that the other way. And that was for number 5. Yep, 1 minus square root of 6. Okay. Number 6, I'm going to square this square root of x, so the square root of x squared is x. And then I'd have minus 3 square roots of x plus 3 square roots of x. So those two middle terms will cancel each other out, and then 3 times negative 3 is negative 9. And that is the answer. For number 7, those are both perfect cubes. So the cube root of 8 is 2. Cube root of 27 is 3. And so our final answer is 5. And then for number 8, we could pull out some perfect cubes. Let's see. So this would be 8 times 2. So 16 is 8 times 2. The biggest perfect cube that's a factor of 125 is, 250 is 125 times 2, right? So the cube root of 8 is 2 cube roots of 2 plus 5 cube roots of 2. So the final answer would be 7 cube roots of 2. That will be our final answer. All right, guys. One more section for chapter 9, and that's it.